Hello everybody, I'm Alberto Martinez and welcome to the first video of this shader tutorial about dissolve shaders using Unity shader graph. This video is motivated because people liked a video that I posted a few days ago with two different dissolve shaders. I decided to make a three-part tutorial about dissolve shaders with the basics and two advanced effects. The first effect that I did in that video is a dissolve shader using a distance-based mask. The second effect, instead of using a distance-based mask, I was using a height mask in local space. First, I'm going to do a short brief about the structure of the series and what are we going to do in each part so you can have an overview of the topic at hand. The tutorial is going to be structured in 4 steps. First, the basics of dissolve shaders, alpha clip materials and its basic variables. Second, we are going to learn how the distance-based dissolve shader is done, and we are going to iterate over the basic stuff. Third, the height-based dissolve shader. And last but not least, a small discussion of examples in games, advanced techniques, and how you can implement them following the basics. They are not that difficult. You should try them. For the first shader, the basic dissolve, we are going to learn how to have a normalized variable as a main input, the basics of alpha clip materials in Unity, how to implement a noise mask, and how to create the emissive mask and its color. So let's start. I have a project in Unity. I already have something with dissolve in the scene, don't worry about that. So what do we need? We need a compatible version of Unity with shader graph. Shader graph requires the new version of lightweight render pipeline or a high definition render pipeline. Let's check how do we create a project. It's super easy. So if you have Unity Hub installed, like I do, here in new projects, just create a new one, just create a new project, and you will get a template of the project. You could use the 3D. This is the built-in render pipeline. But you have to manually install high definition render pipeline and lightweight render pipeline. I'm not going to discuss which one is better. I just use this one because it's easier to set up a scene and ready to go. But of course, the shader that you develop here is going to work also in here. So just create a project, empty scene, put a camera in the scene, put some mesh, cube, sphere, or capsule like I did, and let's get it to work. So first thing first, we need through the package manager, which is this window, you go to window, package manager, and you get all the packages. Here you have a drop down that says in project all packages. If you go to all packages available, you can choose shader graph. Just install it and you will be able to work with shaders. So first I'm going to get, yeah, well, first I'm going to show you, this is the effect that we want with the basic. This is a shader, a value that goes between 0 and 1, as you can see here. And in the way it just dissolves. We have parameters for the noise scale, how much noise do we want there, how big the border is going to be on the ramp color, and the emissive color in case you really want to change it to something, I don't know. You are free to do it. Okay, so we are going to make this shader. I already have it, but don't worry, I'm going to redo it. Just getting rid of this. I'm going to create an empty 3D object. This case is, yeah, it's going to be a capsule. I like to work with capsules. What more? Yeah, we're going to set up a material first. and here in material, my basic dissolve. And this is going to be my material. Now I'm going to create the graph and assign the shader. The graph is just a shader. So I have a folder here with shaders. I have already the 3 shaders, but yeah. Right click, create shader PBR graph. I'm going to, you could work with a lit, but I'm going to use PBR because later maybe you want to put metallic masks, roughness and stuff and diffuse. But yeah, a PBR graph is okay. So I'm going to create it and name it. I'm going to call it my basic dissolve shader. Now that it's created, we just assign it to the material. Here you have a dropdown at the top. You choose and you have to go to shader graphs. It's automatically nested in this subcategory. Just click here and you have all the shaders. If you see, I have practiced a bit. So yeah, my basic dissolve shader. This is the one that we want. And as you can see, it's empty. It's just an empty shader. And let's assign this to the capsule. Now the capsule has my shader. So now if I start switching between the shader graph window and the scene view, I can see the results in real time. Okay, so let's open my shader. And here it is. This is the panel for basic dissolve for shader graph. Here you have a view. You can rotate the sphere. You cannot see it, but you can right click. For example, use a cube and you can rotate the cube, zoom in, zoom out, and you get a view of what's going on here. Also, more things here. This is called the blackboard. Here you will have all the variables. A variable is created in order to avoid fixed values in the shader, so we can easily modify them later. For example, when I go to my dissolve material, everything that I have here is a variable in the shader. So you define it and later you just change it, okay? So we're going to define a few variables. I already told you that we're going to define one main variable called dissolve amount. How do we define a new variable? Here, there's a plus button. Plus, you have to choose the type of the variable. If you don't know the types, you can look forward some basic stuff about programming languages, and it will explain to you what kind of type means vector2, vector1. So I need a vector1. I'm going to call it dissolve amount. We have alpha and alpha eclipse threshold. I think that alpha doesn't work because we are working with opaque surfaces, but alpha eclipse threshold works. So I'm going to change this to a plane. Quad, yeah, here. This is just a quad, right? And let's see what is this doing. It's safe. The value that this variable has have right now is 0. If I put it to 0, it does nothing. If I put it to 1, it does nothing. If I put it to something like 1.5, the quad disappears. Why? Every value that goes beyond 1, as you can see here, makes the pixel disappear. A shader is a piece of code that gets computed, not always. It's like this, but you can get the rough idea. It's computed for every pixel. So this is like a rule, like, hey, do you have an alpha eclipse threshold below 1? Yes, okay. You and the GPU draws that pixel. If you have a value higher than the threshold, your pixel gets discarded. This thing works differently in the different engines, but at the end of the day, it's the same. You can make it disappear at will. Um, but we don't want to make it disappear at the same time. So we are going to use We're going to delete this. I'm going to keep it here. I'm going to use something called a new node. Right click, create node, noise, simple noise. Okay, this simple noise value. Here, for example, you can, in this noise, you can change the scale, reduce the number, and you get this random uh, noise texture here. Okay, if you just plug it to the alpha eclipse threshold, it does nothing. Why? Because this texture is a texture that goes from 0 to 1. If we want this texture to do something, we have to add a bit of value. So let's look at this. I'm going to just add something. I'm going to add 0.1. 0.1 alpha eclipse threshold. It just goes away. 0.5. Okay, now. So look at this. By adding a value to the texture, I'm just brightening the texture. It goes to white. Every value that is 1 means white, 0 means black. So here, every value that goes white, I'm going to exaggerate this, 0.7. No, too much. Maybe I can reduce the scale so it gets super big here. You see here these gray areas in this side? These are the gray areas. Those are values that are below 1. The rest of the texture is above 1. So it means your pixel gets discarded. So if instead of just plugging here and adding a number, I just add a value between 0 and 1, just like that. Go to my dissolve shader. For example, this is by default 0.5. Yeah, let's go to the shader. It's already here if you go to the material, so you can change it here. We have a slider, and you already have a dissolve effect. It's just like that. This is making the material go away, let's say, with a value from 0 to 1. It actually goes to 1.5. Okay, don't worry. Just something I can correct here. So that's the idea. This is the basic idea of a dissolve shader. A value that goes from 0 to 1 that can be changed in code, animated, or whatever you need to deal with it, and an alpha clip threshold value that goes above 1. So one thing that is very useful is to have a lot of variables so we can control how this thing looks. Here we have a noise scale, okay, right? You can just add a new number, new vector one, call it noise scale. This value, if you like, 25, okay, let's say 30. 30 is the default value. Just put it here, save the shader, and go to your material, and you have it here in your material. Now you can change it on your material as you wish. So this is what I like to group stuff. This is what I call the dissolve mask. Let's make the border that goes here. For that, we are going to use the emissive channel. And we are going to kind of work a bit with the result of this mask. So first, I always do this. Sometimes I just leave it out, but yeah. I use a clamp. What is doing clamp? Clamp is making all the values that be in the range 0, 1. If a pixel is below 0, it will be 0. If it is above 1, it will be 1. So with this, I know that the values are completely normalized. In here, I need the values to be be above 1, so this thing works, but here not so much. So I just start clamping the values and then treating them. I want a border around this. For that, I just need to work a bit with the values of the mask. For that, there is a node called remap, very, very handy and very useful, that does the following thing. It translates this value that it goes in from the range mm, in, let's say it's called in, range in, to the range max out. So we know that this value goes from the range 0 to 1. And then we can transform this value, for example, from the range 1 to 2. So you are not going to see nothing here, but this means if there is a 0 here, you will get a 1. If there is a 1 on the input, you will get a 2. If there is 0.5, you will get 1.5. By doing this, we can work with the values. But just look at this. If I just remove a bit of the zeros there, just using -40, and then I'm going to clamp the values again because Unity doesn't like, I'm clamping from 0 to 1. Unity doesn't like black emission values, below 0 emission values. So I'm just, put this thing on the border. We cannot see it clearly, but we already have something. It's because the albedo. I'm going to just add a color variable and I'm going to call it albedo. Right. And it's going to be by default black. I'm just going to plug it here. Now, the black surface is because of the albedo value, and the white surface is because of the emissive. This white is our border. If you see here, I can change the remap value and get different kind of borders. So as you can see, it's kind of not intuitive because if it goes closer to 0, it gets bigger, and if it goes more negative, it gets smaller. Okay, let's create a new parameter like we did with albedo. Just new color variable and call it emissive color. Okay, by default, yeah, here you can have, this color. This is a plain color, let's say, but Unity has a HDR. HDR are colors that go beyond the range of classical RGB. In Unreal, for example, you can just type instead of red 1, you can just type 2000 or something like that. Here you have something not that similar, and then you have the intensity value. You can just crank it up, and then you get a nice color. Let's put it here. And then how do we mix a mask with a color? Just multiply. Just drag, drop, multiply, put it here, and put it on the mission. It's almost white. Not cool? Yeah. We will have to play with this a bit. I will explain to you how do we get this glowy effect. But yes, this is our shader. It's almost done. I'm missing one parameter so we can set it up perfectly. So I'm going to group all of this again, group selection, and I'm going to call it emissive border mask. So this is our shader. It's super simple. I'm missing one parameter, but it's super easy to do. As you can see here, my border is glowing. Maybe your border is not glowing yet, even if you have the intensity value cranked up. Mine is glowing. If I increase the intensity on the HDR color picker. But how do we fix this? This is easy. It's just a post-process volume with bloom. I deactivate the bloom, it goes away. So I'm not going to explain how to do post processing. You can type it in. The documentation for the post processing is all in the Unity forum. It's not going to be the same in the HDRP pipeline. Okay, it's completely different. This is either the classic Bloom post process or the lightweight rendering one, but it just works the same. So anyway, Bloom intensity HDR color, you get nice glowing border. So the idea is almost done, but as you can see, I can change how much I want this to be dissolved. I change can change the noise scale in case I want different kind of effect. This is also cool. But I cannot change how big is the border. We need a new variable. That variable is a vector one. I'm going to call it border size. If I just, you know, put it here, if I plug it here, it doesn't work because it will get exactly the same value to the x coordinate and the y coordinate. And for that, just drag drop from here. And we are going to make a vector 2. Vector 2 has two inputs, right? And we're going to plug border size to x and the y is going to be 1. And now compile. Go again to our shader. Oh, this is looks really bad. Maybe it's because of the border. Yeah, the border size. So this is a basic dissolve shader.